Lecture number 5, Tectonic Landforms, refers to the folding, faulting, and doming of the Earth's crust. So we have three big topics in this lecture. We're going to begin with folding. And so what happens is you take what was once flat-lying sedimentary strata and you add compression by converging tectonic plates, and you wind up bending rock. So a rock can actually bend or fold. And so here we've got layers of sedimentary strata that's been folded by plates compressing together. Now what you wind up with, right, are anticlines, right? That's the term in geology you need to know, and that represents an upfold of sedimentary strata. Now that's going to wind up creating a mountain range, right, an anticline. And then the opposite, a downfold, is the syncline, and that downfold, syncline, is going to make a valley. All right, and so here's some examples in the Appalachians. I mean, here's a road cut that is cut through a mountain ridge, all right? And you can actually kind of get a feeling for the upfold, this anticline here. And here we're going through a mountain ridge, but they've tunneled through the anticline, and you can actually see just a portion of that upfold. Now, it's kind of hard to get a syncline picture, okay? But this is just a small scale example of a downfold right into here. All right. Again, we're going to do really good examples of each of these features. Definitely the best example of a folded landscape, right, are the Appalachian Mountains, particularly in Pennsylvania. Now, the Appalachians, extends really from New England all the way on down to Alabama, but it's particularly the folded section in the state of Pennsylvania. And what you wind up creating are parallel and linear mountains and valleys. Parallel and linear. And so here I've got an example. Now, this is a high altitude infrared satellite image of the folded section of the Appalachians in Pennsylvania. So I've added some arrows to show the sedimentary strata was compressed. And infrared, the green trees, okay, turns out red, but it looks kind of funny because it is such, high altitude. But these are all the anticlines and synclines. So you wind up with a whole series of mountains and valleys, right? Now, actually, in Pennsylvania, I'm standing on an anticline, and there's a syncline, and there's an anticline over there, and then on, syncline, anticline. So it kind of continues, and so you wind up with a series of folded parallel mountains and valleys. All right, we're going to move on to faulting. Now, what a fault is a fracture in the Earth's crust. Now, the key word is movement, right? In order to be a fault, there's got to be movement on either side of that fault line fracture. So it's not just like a joint, all right? You've got to have movement. Now, I'm only going to really give you two basic types of faults, the really common types. So, if you had a geology class, you would go over several more. So I'm going to give you, the first one is called a normal fault, a very common type of fault. That's why it's called normal. I mean, it's kind of the normal situation. And what you're going to wind up, all right, the type of movement, all right, that's created along a normal fault is vertical movement, up and down movement. And this is due to rifting. Now, we introduced rifting in regards to the pulling apart of the seafloor of the Atlantic Ocean. So again, we've got rifting or pulling apart. Now, what we've got here is pulling apart on the continent. All right, pulling apart on the continent. And so what winds up happening, all right, is the rifting and the movement along the fault. It's not just simply straight, pulling apart. What winds up happening is usually one block, as it's called, one block on one side of the fault line winds up being upthrown as it's being pulled apart. And then the other block of rock winds up sliding on down the fault. And so you wind up with vertical movement creating a mountain and a valley by rifting or pulling apart. So that's really important. And so what you wind up with is creating a mountain range. So the upthrown block, you create a mountain range, and it's called a fault block mountain, right? Block of rock along the fault. Now, this is really a mountain range. You'd have rivers and whatever eroding and creating mountain peaks and what have you. Now, the thing about fault block mountains is that there's no foothills, right? You literally can put your finger, okay, or your foot right, along the fault line. And the mountains range just rises directly right on up. And then the down-thrown block that slides on down is going to wind up creating the valley. All right, now the best example, all right, of a fault block mountain range is the Sierra Nevada mountains of California. And I've talked about them already in regards to orographic precipitation. But right here, I put in the fault, the normal fault, all right, the normal fault right here, just kind of facing Nevada. And what's happened is on the western side, this is the upthrown block, and it's tilted on up, and it's been tilted up 14,000 feet. I mean, it's amazing. And then the downthrown block creates Owens Valley here in Nevada. And here we've got, I mean, this is it. I mean, here's kind of the side view. Here's the normal fault right here, okay? And as you can see, you actually create mountain peaks, all right? So it's not just, a square block, all right? But this is a fault block mountain. And here's just, just one individual mountain peak from Owens Valley. And again, there's no foothills. It's just basically the fault line, and the mountains rise on up. And so that's our best example in the United States of a fault block mountain. All right, I've got this called 1A because this is actually a type of normal fault. So now this type is called Horst and Graben landscape. Now these are German terms, Horst and Graben. And this occurs when you've got a series of, several parallel normal faults. All right, so you have a whole bunch of normal faults lining right on up. You could have hundreds of them lining right up instead of like one large single one that we had with the Sierra Nevada. And so what you wind up creating, instead of just one giant fault block mountain, are a whole series of mountains and valleys, mountains and valleys. And so what you wind up with are horsts. Okay, horsts, and this is the upthrown block, all right, so we're still rifting and pulling apart, and you wind up with, it's just not simple pulling apart, you wind up with usually an upthrown block and then a downthrown block. And so you wind up with a mountain, that's the horst, right here, so you wind up with a mountain range, and then the valley is called a Graben. Now, I know for sure that in German, Graben means grave, and so that's how you can remember that forms the valley, and that's the downthrown block. So what you're going to wind up with is a whole series of parallel and linear mountains and valleys. Now, it's not unlike the folded mountains of the Appalachians in Pennsylvania. You wind up with parallel linear mountains and valleys from folding, but in this case, it's faulting. And so you have a whole series of normal faults, parallel normal faults. And they're only showing two here, but there would be dozens and dozens and dozens of them creating Horsts and Grabens. Now the best example, right, is basically the state of Nevada, right, just immediately to the east of the giant normal fault creating this Sierra Nevada mountain range. But here, this is on the interstate, just off the interstate, just north of Las Vegas. And the interstate, of course, is in a Graben, and then in the distance is a Horst, and then there'd be a Graben and a Horst and a Graben, and on and on and on. And like I said, our best example is the entire state of Nevada. This is a physical map of Nevada, and there's kind of amazing, funny looking, but these are all here's the Horst and a Graben, and Horst and Graben, Horst and Graben, and on and on and on. And so, really beautiful example, basically, through almost the entire state. Now, here's Las Vegas, way down in the south. It is in a Graben, all right, and it's surrounded by Horst mountains here. And this right here, it's probably just, my goodness, maybe a 20 or 30 minute drive to the west outside of Las Vegas is a state park. It's called Red Rock State Park. And it's a beautiful example, of a Horst mountain range. And here it is here, right? And so, this is a beautiful example of, rifting, pulling apart, and one block of the Earth's crust is, tilted upwards. And so it's kind of a nice example of, a tilted Horst in Red Rock State Park. And you can go in there, you don't want to go there in summer, obviously, but they've got it, the visitor center and the museum, and they'll tell you all about Horsts and Grabens and normal faults. All right. Okay, so I'm just going to give you two examples of faults. This second example is called a transcurrent fault. Now, again, you've got to have movement, but in this case, the movement along the fault line is horizontal, all right? Horizontal. So you're not going to wind up creating, giant mountain ranges. And so this is the rift zone, the pulling apart, all right, along the transcurrent fault, but the movement is side to side. Now, the best example of a transcurrent fault in the United States and probably even the world is the famous San Andreas Fault of California. And, I've kind of highlighted, the main course of that fault line. And so it pretty much goes through San Francisco, all right? And see, there's Los Angeles, and then there's San Diego and on. So there are many, secondary faults, but this is kind of the main course of the San Andreas. And then you've got, of course, the subduction zone, further in the Pacific Northwest. But basically, this is the thing is coastal California, where you've got all the big cities from San Francisco to Santa Barbara, Los Angeles, and San Diego. Coastal California is actually not part of North America. It's not part of the North American plate. It's actually part of that giant Pacific plate that's been moving in a northwesterly direction. And so the horizontal movement or rifting is mainly due to the Pacific plate moving in a northwesterly direction. And actually, flying over, if you're flying into San Francisco, or you might be lucky enough to, if you look out the window on a clear day, you might actually be able to see the rift. And here's the San Andreas Fault here. And now, of course, there's going to be a lot of crushing and crumbling of rock, with movement of the plates. So there is some relief created. Some hills and things like that along the rift zone. But it's basically the Pacific plate that's moving, in regards to the more stable North American plate, with the rest of the continent. So if you really kind of think about it, like thinking, 100 million years from now or millions of years from now, I mean, where is coastal California going to be? It's going to wind up being an elongated island, in the North Pacific. Okay. All right, so the third and final feature is doming of the Earth's crust. Doming of the Earth's crust. And this is due to the pushing up of magma. So, you've got a hot spot, and, the hot magma's rising, right? Hot, and it's kind of like convection. Hot material is rising. And literally, this rising magma can push up on the rock of the Earth's crust and actually deform the Earth's crust. In this case, we've got sedimentary layers, sedimentary rock that's deformed. And so I'm just going to show you kind of three stages in the formation of a mountain range due to doming of the Earth's crust. And these stages, this takes millions and millions of years. So classic geologic time scale. And so what's going to wind up is we've got flat-lying sedimentary strata, right? And then this is the symbol usually for igneous rock, like igneous or metamorphic rock there, yeah. And so we're just going to say we've got the pushing up of a hot spot of magma, and then the hot spot dissipates and cools. But anyway, so what you wind up with is what was once flat-lying sedimentary rock. Now it's kind of deformed, right? Deformed and curved on up to form, a mountain dome. Now, millions of years later, all right, erosion is going to start to take over, and the erosion is going to start at the top of the dome. That's where you've got the greatest erosion, at the summit of mountains. And so we're going to start to strip off layer by layer of the sedimentary strata, all right, at the top of the dome. All right, so now we're going to move on to the stage 3. And what we're going to do is we're actually going to expose the granite, and it's going to form a big granite mountain range. There we go. Yeah, so here we finally, by erosion, stripped off layer by layer of the sedimentary rocks that were deformed, and now we expose the granite, and then through river erosion and things like that, you wind up, creating a mountain range. And so we've got the granite mountains are eventually exposed, all right, and there is a characteristic feature, all right, surrounding the granite mountains. It's kind of a funny name, but they're called hogbacks, right? They're the eroded edges of the steeply dipping sedimentary strata surrounding the dome. So remember, the sedimentary strata was, tilted on up, and so dipping or tilted. And so you've got the remaining eroded edges. And the hogbacks appear as like sawtooth ridges. And it's because, rivers draining the granite mountains, the rivers in their valleys kind of cut on through the sedimentary strata and cut valleys. And so what you wind up with is, here's a good example of a river valley here. And so what you wind up with are just kind of remnants of usually it's going to be this stronger sandstone. This yellow here is the sandstone. It's a little bit more resistant, and so it'll form, a stronger feature in the landscape. And then this gray shale, that'll erode away, and then you might have another sandstone layer, with secondary hogbacks. And so again, it's, it comes down to rock structure. And so it's usually this, the stronger sandstone that remains in the landscape to form these interesting features, these hogbacks. Okay, so like I said, for each of these landforms, I've got the best example in the United States. And for doming, that's the Black Hills of South Dakota. And here's a satellite image of the Black Hills dome, and it's granite, big massive granite here, and in the northern Great Plains. Now, what we have is really a big time, we're kind of in the latter stage of erosion, and the hogbacks are pretty much eroded. Here's some hogbacks here, but there was once sedimentary cover surrounding this entire dome, but it's really been really well eroded. And so here's kind of just a map diagram showing the Black Hills dome. All right, and here we've got kind of a cross section of the tilted sedimentary strata, and then the exposed granite core, right, forming the Black Hills of South Dakota. And it's kind of on the eastern side where you've got the best hogbacks. And it's a sandstone, a little bit more resistant sandstone ridge. And, all rock formations are named, and this one is called the Dakota Sandstone, that's forming the hogback ridges that are best seen kind of on the eastern side. Like I said, here's the eastern side here. All right, so you might go to the Black Hills if you ever want to visit a national park. That's where the presidents are carved in the granite at Mount Rushmore near Custer. All right, and it's kind of neat to see. Let me show you. When I was there, it wasn't the best day, but so here's some hogbacks here, all right, and so really thick sandstone layer, and it kind of looks like the teeth of a saw. All right, so there's a nice hogback there, and it's forested, and then you've got the big, granite mountains in the distance. And here's another example here of some of the, the sandstone hogbacks, and then the granite mountains in the distance. And here's another example. This actually isn't near Mount Rushmore. Actually, this is near the Front Range of the Rocky Mountains near Denver and Colorado Springs. It's kind of the same thing. The Front Range, was a big, massive granite that was folded upwards, and all the sedimentary strata was deformed. And so near Denver, you've got beautiful examples of hogback ridges. And then the granite mountains of the Front Range of the Rockies, is all exposed granite. And so there's been massive erosion, all right, of what was once, the sedimentary cover that was deformed. And so beautiful hogbacks. So if you ever go to Denver or Colorado Springs. And end lecture.